Today's lesson is going to talk about a different way to find a solution to a system of equations. So far all we know is how to graph. So let's just kind of review if this is your system, right? Two equations. So we're going to graph each one. We're going to start at 3, and we're going to go up 1, right 2, down 1, left 2, and one more time. And then for the second one, we're going to start at -1, and we're going to go up 2, right 1, up 2, right 1, up 2, right 1. There we go. So it's a little off the grid, but it looks like this might be the solution. 1, 2, 3, 1, 2, 3, 4. So it looks like 3, 4 is the solution. We can check that real quick. Always good to check an answer. So we're going to do 1/2 times 3 plus 3 and see if we get 4. And then we're going to do 4 equals 2 times 3 minus 1. So we're just going to plug that in for x and y, and we're going to work it out. So for this one, I get 3 times 1/2 is 1.5. And for this one, I get 6 minus 1, which is 5. All right, so that doesn't work. In today's lesson, we're going to teach you another method to solving systems of equations. So before, all we know really is how to graph the system, and then we look for the intersection. So really quick, if you were to try to do this with graphing, okay, we start at 3, we go up 1, right 2, down 1, left 2, and then we're going to graph 2x minus 1. And we're going to draw our lines. All right, so this has not happened to us yet, but our intersection is off grid and might not be very accurate. It looks like 3, 4 might be where they intersect, but you'll find if you put this into the first equation, so if we do 1/2 times 3 plus 3, that will not get us 4. So they intersect somewhere, but it's not at 3, 4. It's really hard to tell. So in this case, graphing probably isn't our best friend. Other situations would be if you were asked to solve this system, that's going to be really hard to graph the decimals. Or if you have a really big number, like your slope is 100, you're not going to want to count that on a coordinate plane. So these are all the drawbacks to graphing. They're not very convenient for big numbers, decimal numbers, or even if they don't intersect at a nice pretty point. So that's why it's always good to have a backup method. So today we are going to focus on substitution. So how it works is you'll still be given 2 equations. What I want you to do is you're going to pick one equation to work with. So you can work with the top or the bottom, it does not matter. And you're going to solve either for x or for y. So I know we're used to solving for y, but you can also solve for x because this is substitution. We're not graphing. So you don't have to solve for y. What I like to do is I like to take a look at the picture and think, what is going to help me avoid doing a fractions? So for example, if you were to solve for y in the top equation, you would get y equals negative 2/5 x plus 9/5. So that's legit. You can work with that, but it's not very convenient. So I probably wouldn't use that one. But when I look at the bottom, I realize, hey, x doesn't have a number in front of it, so I won't have to do any division, which means no fractions. So what I'm going to do is I'm just going to add 2y to this side. And the main goal is you want to have a letter by itself. So now x is all alone, which is great. So step 2, so we did step 1. Step 2 says you want to take your answer and basically substitute it into the other equation for that letter. So what we're going to do is we're going to take 2y and we're going to change our x into 2y because it's the same thing, so you can switch them in and out. You don't want to put it back into the equation you started with because you're just going to get 0 equals 0. So if I were to plug this into the top equation, I always use parentheses when I substitute. And then everything else you're going to copy as is. So the 5y will stay and the 9 will stay. So just recap, instead of x, I changed it into 2y. And now we can actually solve this equation because we just have y's. So we get 4y and 5y. We make 9y. So we get y equals 1. So that's probably the trickiest part, is isolating a letter and then substituting that answer into the other equation. So it'll take some practice. And then all you have to do is, since you know that y is 1, now you got to go back and figure out what x is. So we had two equations. We had x minus 2y equals 0, or you can use the first equation, 2x plus 5y equals 9. Since we know y is now 1, we're going to change y into 1, and you can work with either equation. It does not matter. So maybe some of you will work with the top equation, maybe some of you will work with the bottom equation. It's not going to matter, we're going to get the same answer either way. So just to kind of save on time, I would get 4 and 2x, so I get 2 if I solve this. And when I do this, if I add 2 to the other side, I still get 2. So either equation, it doesn't matter where you put 1 in as long as you put it in for y. So we're basically going to work on following those 3 steps. So this is just going to come from a lot of examples, a lot of practice. So I'm looking at these problems, I'm trying to think which letter would probably not involve division, hence no fractions. So like if I get y by itself, I have to divide by 2. If I choose to get x alone, I'll have to divide by 3. I'll have to divide by 5. Oh, nope, don't have to divide here. So I'm going to focus on isolating x in the top. So if I want to get rid of the 5y, I just have to subtract it from both sides. So I'm going to have minus 5y here, and I'm going to get nothing left over here. So now I can rewrite this as x equals negative 3 minus 5y. So since all of this is equal to x, that means wherever you see an x, you can change it to that expression. And remember, you want to use the other equation that you didn't touch yet. So instead of x, I'm going to change it to negative 3 minus 5y. And make sure that you put that in parentheses. Always use parentheses when you substitute. All right, so we're just going to go through and we're going to solve that really quick. And we get negative 1. So you can take that negative 1 and you can put it in to this equation. You can put it into this equation. You can put it into this. It does not matter. You can put it into any of these. So I usually like to do the first one. So I'm going to do x plus 5, but this time I know y is negative 1. And then if I were to solve that, I will end up getting positive 2. So my answer as an ordered pair would be 2, comma, negative 1. So just make sure if it says write your answer as an ordered pair, you want to make sure you do that step. Let's go down and try it again. So when I look at these, I definitely want to work on getting x by itself because I don't have to do any division. I won't have to work with any fractions. So I need to add 3y on both sides. So I like to just write plus 3y and then cross it out on this side. So now I have x equals negative 9 plus 3y. And now we're going to take that expression and we're going to put it in for x up top. So I want to see 5 parenthesis negative 9 plus 3y. So that's your new x. Everything else you just kind of leave alone. Right, and then we're going to go through and we're going to solve it. All right, so we are going to get 4 for y. Okay. And then we need to go back and figure out what our x is. So you can use any of your equations. It doesn't matter. I think I'm going to use this equation this time, just to kind of show you that it works. So we're going to do 5x. This time I know y is 4 equals 7. And I'm going to get 5x equals 15, so x is 3. And what I'm going to do is just finally make my answer an ordered pair, as that's what the directions say. So if I were to graph these equations, they would cross at 3, 4. In this one, okay, if you look at all your letters here, they all have a coefficient, so all of them are going to require division, but that's okay. So all you got to do is just pick a letter that you think will be easy to work with. Maybe you want to get y by itself here. So we're going to need to subtract 6x to the other side, and then we'll have to divide everything by 3. Hopefully you realize that 3, 6, and 9 are all divisible by 3. So that means, guess what? You have no fractions to worry about. So in this case, I got y by itself. So I'm going to take this expression, but this time I'm going to put it in for y, because all of this is the same as just y. So you can change y into all of this. So now I'm going to do 2 times negative 2x plus 3 plus 6 equals negative 3x. So now it's not such a bad problem. And I am going a little quick through my math here, so don't freak out or anything like that. So I end up getting x is 12. So now what you can do is plug that in, substitute that either into the first equation or the second one or the one down here. They're all the same. I'm going to do the first equation, I think. So 3y, but instead of x, you can now replace it with 12. And then we just solve from there. So we should end up getting negative 21. So my solution is going to be 12, comma, negative 21. So just so you know, if you were to graph these lines, that's where they would intersect. So if you're counting by ones, it's going to take you a while to get to negative 21. So graphing probably wouldn't be a very good method for this particular problem. In our last problem, we're going to take a look here, and every letter has a number in front of it. So no matter what, I have to use division. And it does not matter which letter you choose to go with. It should work out. It's just a matter of what's the easiest way out. So I noticed that 3 goes into 6 and 12, so I'm going to choose to divide everything by 3 here. So I'll now have a negative x. Instead of 6, 6 divided by 3 is 2. Instead of 12, 12 divided by 3 is 4. So I just went through and divided, divided, divided. So this is my new equation. And then what I'm going to do is I'm going to subtract 2y from both sides. Then I'm going to divide everything by negative 1. So I get a negative 4 and a positive 2y. So I can take that group and plug it in for x up here, which leaves me with 10y. And then instead of x, we're going to have negative 4 plus 2y equals 3. And then we're just going to go through and we're going to solve that really quick. All right, so my answer is not going to work out nice and pretty. I am going to have kind of a non-friendly fraction there, but we have to be able to work with fractions too, because that does come up in the world. So we can put this in either into the first one or the second. I think I'll go with the first one for this. So instead of 10y, we're going to have 10 times 35, 26. And then we're going to add 8x. Set that equal to 3. And I don't really pick up a calculator to do 10 times 35, 26. What I actually like to do is cross reduce, change 10 into 5 and 26 into 13. And then I'm going to do 35 times 5. So if you need a calculator for that part, that's more understandable, but you shouldn't have to pick it up just to do 10 times the fraction. Sometimes calculators give us decimal answers, and we want to avoid that for this problem. So 35 times 5 is going to be 175. And you just keep 13 as your denominator. And you just kind of go through here. I don't really feel like converting 3 into a fraction and combining it with that. It's a little bit hectic, so what I'm going to do is just multiply everything in here by 13. So now I have 175. This would be 104x. And then I get 39. We're going to subtract 75 from both sides. And then divide both sides by 104. The last thing you want to do is, I notice that these are both even numbers, so I know they're going to reduce. I just don't know by how much. So just because I don't like doing a ton of work, I'm just going to try a couple numbers here. I'll try dividing by 6. Nope, that doesn't work. We can try 136 divided by 4. So we get 34. And let's see if 104 works as well. All right, so that does work. So I'm going to get negative 34 over 26. And I just noticed they're still even, so I can divide them by 2. And I get x is negative 17 over 13. So sometimes these questions, when you're doing substitution, it's not going to work out all nice and pretty, but I wanted to show you how to handle a fraction situation if it occurs.